Mars, the rusty red planet next door, a barren world of rocks and dust, or so we thought. Recent discoveries have turned that image upside down, revealing a planet brimming with secrets that challenge everything we know about its past and potential for life. From bizarre rocks with mysterious spheres to a hidden ocean locked deep beneath the surface, the latest findings from our crimson neighbor are nothing short of astonishing. This is a story of scientific wonder, unexpected twists, and a glimpse into a Mars that might have once mirrored Earth in ways we're only beginning to grasp. Let's start with a rock, because Mars is a treasure trove of them and some are downright peculiar. Early in 2025, the Perseverance rover science team stumbled upon a standout specimen nicknamed St. Paul's Bay. At first glance, it's just another Martian boulder, but a closer look reveals something strange. Tiny spheres, just a few millimeters wide, embedded within it. These aren't perfect little orbs either. Some are stretched out, others have sharp edges, and a few even sport tiny holes or look like they've been cracked open. On Earth, similar microspherals often hint at volcanic eruptions, where molten droplets cool into balls mid-air. Could a massive asteroid impact have splashed molten rock across Mars, forming these oddities? Maybe. But their size and irregularity complicate that theory. Another possibility ties them to the famous Martian of blueberries, those hematite-rich spheres found by the Opportunity rover in 2004, or even the spiral formations Curiosity spotted in Yellowknife Bay. Are they all cousins, born from some ancient process we don't yet understand? If scientists crack this puzzle, it could rewrite our understanding of Mars' geological history, hinting at a planet far more dynamic than the desolate wasteland we see today. But St. Paul's Bay isn't the only rock turning heads. Just weeks earlier, Perseverance captured an image from G0 crater of another oddity, a rock that seemed out of place, like it had been dropped from somewhere else entirely. Mars is full of these geological nomads, scattered by forces like wind, erosion, or even ancient water flows we're still piecing together. Intrigued, the team zapped it with LIBS, laser-induced breakdown spectroscopy, a high-tech tool that blasts a mineral with a laser and reads the light it emits to reveal its makeup. The result? A soft white silicate clay called kaolinite, slightly different from Earth's version, alongside traces of spinel, a magnesium-aluminum gemstone. On our planet, kaolinite forms in warm, wet conditions. Think lush rainforests or steaming hydrothermal vents, environments ripe for life. Finding it on Mars is a tantalizing clue that, at least in pockets, the red planet once had Earth-like conditions. Was this a fleeting oasis billions of years ago, or a sign of something more widespread? Each rock like this adds another piece to the puzzle of Mars' watery past. That past got even more intriguing with another find. Leopard-spotted rocks first spotted a year ago that hint at something alive, or at least chemical mischief. These speckled stones suggest bacterial activity, a possibility bolstered by the fact that a purely natural reaction would need scorching temperatures unlikely in their location. Then, just days before these latest revelations, NASA dropped a bombshell: the largest organic molecules ever found on Mars. Decane, undecane, and dodecane, complex hydrocarbons with 10, 11, and 12 carbon atoms, turned up in samples. On Earth, these are tied to fatty acids, the building blocks of cell membranes. Could they be biosignatures of ancient Martian microbes? Maybe. Or they might stem from geological quirks, perhaps hydrothermal events long extinct. The jury's still out, but these discoveries pile up like clues in a cosmic detective story, pointing to a Mars that might have teetered on the edge of life. Speaking of Mars' signature hue, scientists recently cracked a long-standing mystery. Why is it so red? For years, we assumed it was hematite, an iron oxide common on Earth. But a meticulous study using data from the ESA Trace Gas Orbiter, NASA Mars Reconnaissance Orbiter, and every active rover revealed the true culprit: ferrihydrite. This water-rich iron oxide forms in cold, neutral pH conditions, not the warm, acidic ones we'd expect from hematite. Mix it with a dash of basalt, and you've got that iconic Martian orange. This tells us Mars turned red as it cooled and dried out, likely around 3 billion years ago. Before that, it might have been a very different world. Less rusty desert, more blue-green haven. And here's where the story takes its most jaw-dropping turn. For decades, we've wondered, where did Mars water go? Evidence of ancient lakes, seas, and oceans dots the planet, ripples and wave marks frozen in stone, hinting at a wetter era some 3.7 billion years back. Shallow waters, maybe 6 feet deep, once lapped at Martian shores with waves just a quarter-inch high. The prevailing theory was that solar wind stripped it away, breaking water into hydrogen and oxygen that drifted into space. But that couldn't account for all of it. Mars' surface looks too uniform for such a massive loss. Enter a stunning revelation from the InSight mission's seismic data: a vast ocean's worth of water, trapped 11.5 to 20 kilometers beneath the crust. Detected through Marsquax, this hidden reservoir sits in fractured rock, absorbed by a regolith uniquely adept at holding water, unlike Earth's, which lets it slip away. If confirmed, this could explain not just the missing water, but also the occasional wisps of vapor in the atmosphere. It's a twist straight out of science fiction. Think Total Recall's subterranean ice, yet it's beyond our reach, buried too deep for current tech to tap. But not everyone's sold on a watery Mars. Some argue liquid carbon dioxide, not water, shaped its early surface. In Mars' ancient conditions, CO2 could have flowed as a liquid, mixing with water and salts like potassium chloride to mimic the chemistry we see in meteorites. This theory sidesteps the need for vast oceans, offering a leaner explanation for the planet's past. Carbonates, phyllosilicates, and sulfates in the soil suggest a complex brew of liquids, not just H2O. It's a debate that won't settle until we dig deeper, literally. Then there's the wild card. Mars today isn't as still as it seems. Dust devils, those swirling vortices of grit, aren't just scenic, they're electrified. Recordings from 2021 caught crackling sounds as they passed a rover, revealing static discharges from fast-moving dust. Recreated in labs, this mini lightning could zap rovers, habitats, or astronauts multiple times a second, a hazard no one saw coming. And the Marsquax? Thousands strike every summer, clustered in the north, shaking the ground up to 10 times a day. Unlike Earth's water-driven seasonal quakes, these defy easy explanation. CO2 ice shifting with the seasons might play a role, but their locations don't align with avalanche zones. Meanwhile, some quakes trace back to meteor impacts, small craters pocking the surface, a reminder of Mars' thin atmosphere letting rocks through. These quirks paint a planet alive with surprises, both beautiful and perilous. So where does this leave us? Mars is no longer just a dusty relic. It's a world of hidden oceans, cryptic rocks, and restless energy, a place that might have nurtured life, or at least danced close to it. Each discovery pulls back the curtain a little more, revealing a planet as complex as our own, frozen in time yet whispering secrets through its stones and tremors. The Red Planet's story is far from over. It's a saga of lost worlds and new frontiers, waiting for us to write the next chapter.